Okay, so here goes another video, Helpful Aid for Homework 2.5, number 6. So we're presented here with another problem. Now this one makes you think a little bit more about your understanding of a system of linear equations. And so really try to take it step by step and think about what the problem is saying. So first off, I want to talk about what do we know from this problem, okay? So the problem statement says, rides at an amusement park require 3, 4, 5, or 6 tickets, okay? A family purchases 92 tickets and received 2 tickets from a park guest who had leftover ones. The family wants to use all their tickets and want the sum of 5 and 6 ticket rides to be twice as much as the sum of 3, 4 ticket rides, okay? And so the overarching goal here is to figure out what possibly could be the largest amount of number of 6 ticket rides that the family can go on with all of these different constraints, okay? So first off, first thing that we know, we have 3, 4, 5, 6 tickets, right? The tickets can only come in 3, 4, 5, 6, okay? Next, we also know that the family, they have a total of 94 tickets, okay? How did I get 94 tickets? Remember, 92 plus the 2 tickets that they got from, remember, being left over, right? From some random person giving them 2 extra tickets, okay? And now, something else that was stated. They said that the sum, okay? So they said that the sum of 5 and 6 tickets, okay, they want it to be twice, okay? Here I'll put twice. So twice the sum of the $3 and $4 ticket. Not $4, see, 3 and 4 tickets. Okay. So, with this being said, kind of similar to some of the other problems that I talk about, okay, is let's try to define some variables here, okay? Because the thing is, we want to think about, even though the park, right, even though the park only requires 3, 4, and 5 tickets, think about it like this. How many of each of those can I have, right? That's a total of 94, okay? So I'll ask the question again. How many of those 3, 4, 5, 6 tickets, how many of those can I have that will equal 92, okay? So if you're wondering still what I'm saying here, okay, I'm essentially saying how many of the $3 tickets the 3 tickets can I have? How many of the 4 tickets can I have, right? How many of the 5 tickets can I have? And how many of the 6 tickets can I have, right? That will equal a total of 94 tickets, okay? So this is the first thing that's coming into play into my mind, okay? And then also with that, there's this thing about talking about the sum of 5 and 6 tickets being twice the sum of those 3 and 4 tickets, right? So because of that, this is how I'm thinking of in my head. So however many, remember this, you guys, however many 5 tickets I have, because it said the sum, so that plus the 6 tickets, right? I want that to be 2 times the sum, okay? I want it to be 2 times the sum of the, of the 3 tickets, however many 3 tickets I can have, and how many 4 tickets, the sum of those, okay? Of 4 tickets, okay? So I have these 2 equations here. But now I have a whole bunch of question marks, right? Because I'm saying how many of those, okay? So this is where that whole idea of a system of linear equations come into play, and us defining variables, right? And these, remember, these variables are, they're values, okay? They're values that the variable can take, right? So think about it like this. I could have 3 tickets here, 4 tickets there, 8 tickets here, 1 ticket there. That could possibly sum up to 94, right? But I don't know. Or maybe if I have 4 tickets here, 5 tickets there, 2 of them there, and 3 of them here, right? I can maybe get a total of 94. But we don't know that, right? And so instead of us trying to like guess and figure it out, we're saying that, hey, let's use a system of linear equations. So what I'm going to do is I'm going to take this, right? And I'm going to scoot it down just a little bit, okay? So I'm going to do something kind of important. Let's define our variables. Okay? So defining our variables. So let's say W, right? Let's say W represents the number of 3 tickets purchased. Let's let X be the number of 4 ticket purchase. Let Y equal the number of 5 ticket purchase. And Z equal the number of 6 ticket purchase. And so I really have been kind of talking about this all in the past tense. So we could say purchases. Like how many of those purchases can we make, okay? So because of that, now let's actually let's redo this problem, okay? Meaning we don't need any of these question marks anymore. Why? Because we've kind of defined the variables that represent these question marks. Remember, those question marks represented values, but we just didn't know what those values could be. We still don't know, so that's why we're using variables, okay? So remember we said we're gonna let 3 represent W. Excuse me, we're gonna, we let the $3 tickets represent $3 tickets. Why? The 3 tickets represent W. We're gonna let 4. Okay, remember that 4. We're gonna put an X with it because that represents the 4 ticket purchases. So behind the 5, we're gonna put Y to represent the 5 ticket purchases, the number of 5 ticket purchases. And 6, we're gonna let Z, right? Remember, we're letting Z represent the number of 6 ticket purchases. Okay. All right, so same thing on the bottom. So 5 ticket purchases, right? So we're just gonna put Y there. 6, we're gonna just still keep the Z because remember 6, that coefficient 6 just representing the 6 ticket purchase, the 6 tickets, right? And Z represents however many that we want to purchase of those 6 tickets. Okay, and then 3 and the W, 4 and the X. Okay. So now we have our system of linear equations, okay? All right, and so now, remember, before we can turn it into a matrix C, we need to make sure that we have all the variables on the same side, okay? So we're gonna rewrite it. Okay, so we're gonna rewrite our linear equations. Okay, so we're gonna have 3W, oopsie, I just said 3W and I wrote 5. So now 3W plus 5Y plus 6X, oopsie, 6Z equals 94. And then what I mean by this is I'm about to take everything, right? Everything on the right-hand side and move it over to the left-hand side, okay? So when you do this, just notice that we're going to have to distribute that too. All right. So this will be 6W plus 8X. Okay. But if we are going to move and move 6W and 8X over to the left, right? We're going to end up having 5Y plus 6Z minus 6W minus 8X. And we'll be left with nothing on the right-hand side, okay? So now I rewrote our equation, but still, we probably don't like the way that it's written because we're kind of used to seeing where if I have X, Y, Z, right, equals some number, okay? We probably like to see it the same on the bottom. Okay? So, now what we're going to do next, okay, we're going to just kind of move this a little bit around, okay? Just going to rewrite it just a little, nothing too drastic, okay, you guys? So it's going to be the negative 6W, all right, minus the 8X, okay, plus 5Y plus 6Z, okay? Now let's go ahead and write this as a matrix. 3, 4, 5, 6. Okay, and it's a total of 94. Negative 6, negative 8, 5, 6. And we'll have 0. And remember, using your graphing calculator, let's do the row echelon form. So I got 1, 4/3, 0, 0, 0, 0, 1, 6/5. Okay. And then we have some ugly numbers over here, okay? Okay. So this is actually perfectly fine, okay? So when you do your row echelon, this is what we're going to get. Now, what does this mean? Okay? So think about that. What does this mean? Okay? Well, according to your textbook, okay? According to your textbook, this means that we have infinitely amount of solutions. All right, so to continue on with this problem, well, if I have an infinite amount of solutions, let's rewrite this matrix, okay? Let's rewrite it now as a linear equation. So we really end up with, so this is W, X, Y, Z, okay? If you forgot, we ended up with, okay, W plus 4/3 X equals 94, 9. And then we have Y, okay, plus 6/5 Z, okay. Remember, we did nothing wrong, all right, okay. And now that equals 188 over 15, okay. So now remember, what was the end goal of this problem, okay? End goal of this problem was to tell us how, and I'll write this, end goal, how many 6-ticket rides can we have? Okay, so 2 things I want to point out, or really 1 thing that I want to point out. But the 6-ticket rides, okay, remember 4 tickets, so 4 tickets and 5 tickets Let me be more specific, 4 ticket and 5 ticket, they cannot sum to 6 ticket rides, all right? So only 3 and 6 ticket rides can, okay? Only 3 and 6 ticket rides can do that, all right? So because of that, reason why I'm saying that, so let's think about it like this. That means, what if we have 0, okay, 0 4 tickets, and let's say we have 0 5 tickets. How many 6 ticket rides can we possibly get, you guys? Okay, so with that being said, I can use either of these equations, okay? So remember, 4 ticket rides was being represented, remember, 4 ticket rides were being represented by the variable X. And remember, 5 tickets was being represented by Y, okay? So what I'm going to do is I'm going to use the second equation, okay, which is Y plus 6 fifth Z equal 188 over 15, okay? And I'm going to let Y equals 0 because we just said that. What if 5 tickets, using that equation, what if 5 tickets, what if we had 0 5 tickets, how many $6 tickets, 6 tickets can we have? I want to keep saying $6. Sorry, you guys. Okay, so we have 0 plus 6 fifth Z equals 188 over 15. Okay, which is really, I'm just going to rewrite it one more time. Okay, so remember, we're just solving for, remember, Z. So to eliminate this fraction over here from the Z, I'm going to do multiply by 5 6 on both sides so that we can cancel it out. And we'll be left with Z equals 188 over 15 times 5 6. And so now when I use my calculator, I end up getting 10.4. Okay, so I end up getting 10.4, but now think about it like this. Remember, I get 10.4, right? So really, how many rides can I get? Okay, how many rides can I get? Can I have a 0.4? No? Okay. With 10 tickets.